Hello friends, myself R.D. Mahajan presenting my video on solution of one-dimensional heat flow equation. Let us try to solve the problem. Solve partial differential equation dou u by dou t is equals to k into dou tu by dou x square for the conduction of heat along a rod without a radiation. Subject to conditions. Condition number 1, u is not equals to infinity as t tends to infinity. Second, dou u by dou x is equals to 0 for x is equals to 0 and x is equals to L. This become a boundary condition as it is defined for two values of x. And third condition, u is equal to Lx minus x square for t is equals to 0 for the condition 0 less than or equal to x less than or equal to L. This becomes the initial condition. And therefore, as it is a problem of one-dimensional heat flow equation, given partial differential equation is dou u by dou t is equals to k into dou tu by dou x square as equation number 1 represents one-dimensional heat flow equation through given rod. Let the solution be u, which is a function of two variables x and t, as c1 cos of nx plus c2 sin of nx multiplied by c3 e raised to minus n square k into t. Then multiplying by c3 inside the bracket, we get c1 c3 as c1 dash cos of nx plus c2 c3 and another constant c2 dash sin of nx multiplied by e raised to minus n square k t. We call this equation 2. Then, as the condition is for dou u by dou x, differentiating this equation 2 with respect to x, keeping t constant, and therefore a derivative of u with respect to x is dou u by dou x is equals to differentiating these terms with respect to x. Therefore, this become a constant term. Derivative of the first term is c1 dash. Derivative of cos is minus sin of nx. Chain rule. Differentiation of nx is n. Plus differentiation of sin is cos. Therefore, it is c2 cos of nx. Chain rule. Derivative of nx with respect to x is n. And this is constant term as it is, e raised to minus n square kt. This term we take outside and differentiation of this term is this one. And we call this as equation number 3, a new equation. In this equation, we use the first condition using condition dou u by dou x is equals to 0 for x is equals to 0. Therefore, the left hand side becomes 0. Right hand side becomes, when x is 0, sin 0 is 0, cos 0 is 1, and therefore it is n c2 dash cos 0 is 1 multiplied by e raised to minus n square kt. Once again, we apply the same concept here, whatever I have used in my previous examples. Here the product of two terms is equals to 0. Condition is for x is equals to 0. When x is 0, t should not be 0. And as t is not equals to 0, this term is not equals to 0. It implies remaining term must be 0. Therefore, that remaining term is there. C2 dash must be 0. Substituting that value here in equation 3, we get dou u by dou x is equals to C2 dash 0. Therefore, we have minus n C1 dash sine of n x into e raised to minus n square k t as new equation number 4. In equation 4, we use the using condition dou u by dou x as 0 for x is equals to L. Therefore, left hand side becomes 0, right hand side becomes minus n C1 dash sine of nx, it becomes sine of n L e raised to minus n square k into t. Condition is for x is equals to L. When condition is defined for x is equals to L, as t is not equals to 0, this term is not equals to 0, but the product of two term is equals to 0. This is not equals to 0. We require to find out C1 dash. If we consider C1 dash as 0, the complete term becomes 0. And therefore, it implies the remaining term must be 0. And that remaining term is here, sine of NL must be 0. Transferring this to other side, we get NL is equals to sine inverse of 0. And the value of sine inverse of 0 is a standard value p pi, suppose. And therefore, we get n is equals to p pi divided by L. Substituting this in equation 2, we get substituting the values of that n and the value of C2 dash as 0. Equation 2 becomes u of x3 is equals to C1 dash cos of nx, n is p pi divided by L times x. This one is 0 as C2 dash is 0. E raised to minus n square p square pi square by L square times kt, and we call this equation number. From this, we write down the most general solution for u as u, which is function of x and t. We replace that C1 dash by the term Cp into cos of p pi by L x into e raised to minus p square pi square divided by L square times kt, where p change, we call this equation number 6. Then using the last condition, u is equal to Lx minus x square for t is equals to 0 in 6, we get the left hand side becomes Lx minus x square, right hand side becomes summation from p is equal to 0 to infinity. When t is 0, this becomes e raised to 0, and e raised to 0 is 1, and therefore it becomes Cp into cos of p pi by L times x. This is similar to half range cosine series, and condition 0 less than or equal to x less than or equal to L. Therefore, RHS represents half range sine series. Oh, sorry, half range cosine series. And as it represents half range cosine series, we require to find out the values of A0 and AN. Here A0 means C0 and AN means CN. C0 is given by or obtained by formula 2 by L integral from 0 to L f of x dx, and in substituting value of that f of x, it becomes 2 by L integration from 0 to L. F of x is Lx minus x square, and then its integration with respect to x. We get 2 by L as it is. Integrating each term with respect to x, it is Lx, its integration is x square by 2 minus integration of x square is x cube by 3 and limit from 0 to L. It becomes 2 by L. Upper limit for x as L, it becomes L. Substituting the value of x as L here, it becomes L square into L, that is L cube by 2 minus L cube by 3 for upper limit. For lower limit, as x is 0, this term becomes 0. Then from this two term I can take L cube common. Therefore it is 2L cube divided by L. Remaining terms are 1 by 2 minus 1 by 3. And the value of that 1 by 2 minus 1 by 3 is 1 by 6 multiplied by 2L square. And therefore we get that value as L square by 3 as the value of C0. Then we try to find out Cn. Cp is given by 2 by L integral from 0 to L f of x cos of p pi x by L and its integration with respect to x. All these formulas as per the half range cosine series. I will provide the link of my half range cosine series in the description box. See that video or watch that video. Therefore it is 2 by L integration from 0 to L fx is Lx minus x square multiplied by cos of p pi by L times x and its integration with respect to x. Integrating this by generalized part, first term is Lx minus x square, algebraic type, and second is cosine term, trigonometric. Therefore this must be the first and this is second term. Applying generalized integration by parts, we get 2 by L. First term Lx minus x square, integration of cos is sine p pi by L x divided by coefficient of x is p pi by L minus the differentiation of this with respect to x. Its differentiation is L minus 2x. Derivative of x square is 2x. Next integration of sine. Integration of sine is minus cos of p pi by L x divided by p pi by L, and again this p pi by L, it becomes p square pi square by L square. Then plus next differentiation of this term with respect to x. Derivative of L is 0. Differentiation of minus 2x is minus 2. Derivative of cos, integration of cos. Next, integration is sine, but with this minus sign, therefore it becomes minus sine of p pi by L x divided by p cube pi cube by L cube plus next is minus differentiation of constant term. The derivative of constant term is 0, therefore we stop here. And limits from 0 to L. When we substitute the upper limit for x as L, this become L get cancelled, sin p pi, and this is also sin p pi. As sin p pi is 0, that term becomes 0. And for lower limit, sin 0 0, sin 0 0, means for upper as well as lower, these two terms become 0, means we have to substitute only for this. It become 2 by L. This goes to numerator as L square divided by p square pi square. We get minus L. Cos of p pi is minus 1 raised to n. N is here p. Minus. And this minus, it become plus. L into 1. From this two term I can take minus L common, therefore it become 2L square divided by p square pi square multiplied by minus 1 raised to p and plus 1. And as it contains the term of minus 1 raised to p plus 1 or 1 plus that, we require to find two different values. What will happen when p is even and what is the value if p is odd, and therefore it is 2L square divided by p square pi square. When p is even, minus 1 raised to 2 is plus 1 and this plus 1. 1 plus 1 we get 2. If p is even, and when p is odd, minus 1 raised to 1 is minus 1. Minus 1 plus 1 becomes 0 if p is odd. Substituting the values of C0 and Cp in this result of half range Fourier cosine series. Therefore, we get the final solution as u of xt is equals to the value of C0 as L square by 3 divided by 2, summation from p is equals to 1 to infinity, the value of Cp as minus 4L square divided by p square pi square. Replace p by its general term 2p. Therefore, it becomes 2p square bracket square pi square cos of p pi by L, replacing p by 2p. Therefore, it becomes cos of 2p pi divided by L times x e raised to minus p square pi square. Therefore, replacing p by 2p, it becomes minus 2p whole square pi square by L square k times t as the required solution of that one-dimensional heat flow equation obtained by using method of separation of variable technique. In my next video, I will discuss two-dimensional heat flow equation, that is Laplace equation, and how we can find the solution of it by applying a method of separation of variable. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.